Thank you, everyone, for joining us. If you would type in the chat where you are joining us from, we would love to see that. This evening or this morning, depending on when you are joining or will be watching this recording, we are going to be talking about in this session 2 of the new Globe Educator 1-week pacing guides. Both of these are focused on using the trees tool in the Globe Observer app, and we'll be talking about one related to plant phenology and another one related to carbon cycle. So we're really excited to get started. Go ahead, next slide, please, Angie. So let me introduce myself. I am Jessica Taylor. I am a physical scientist at NASA Langley Research Center. That is located in Hampton, Virginia, as I see some of your locations coming through. I was actually a Globe student when I went to Florida State. So I went to Florida State to study meteorology and asked a lot of questions about how people learn, and started getting involved in Globe and asked a lot of questions about how people learn. And my major professor, who was a Globe principal investigator, suggested I should take some classes over in the College of Education too. And believe it or not, one of the classes I chose to take was biology, teaching biology, and that is actually how I became fascinated with phenology and interested in carbon cycle. I was always interested in atmospheric sciences and climate, and so biology, finding phenology as part of biology was a way for me to really begin to appreciate another science. So Angie, why don't you go ahead and introduce yourself?
Hello, my name is Angie Rizzi, and I taught middle school science for 12 years in a very small school. So I taught all the science classes in the entire middle school and high school earth science and a math class every year. So that did include the life sciences. And I had great success with Globe with my students. And so when I had the opportunity to join Jessica's team and help other people learn about Globe and implementing it and all the great things you can do with it, I jumped at the chance. And so I'm happy to be here tonight and share with you.
Thanks, Angie. Now, to get started here, oh, by the way, later on in the program, we'll have another person from NASA Goddard joining us to talk a little bit more about how you could even extend this further. So to kick us off, really focusing on trees, we'd like you to type in the chat. What are some differences that you notice between these two photos? And these photos are actually Globe observations that have been submitted to the Globe database. What are some things that you notice? Leaves, differences in leaves, the quantity of leaves. What else do you observe? All right, I see tree roots in rocky outcrop versus compact soil. Yeah, so what is the tree living in? What's the soil? Arid versus temperate climate. We've already, just in all of those conversations, already extended this conversation of trees beyond trees to our other Earth system spheres, right? To atmosphere and to pedosphere. Straight up color, green versus brown. Healthy living trees, dead trees, branching, the differences in just how trees look. Great. These are great observations to get started. And I see another one, differences in sky color, right? And so thinking about how these trees might be connected to our Earth system. Go ahead, Angie, to the next slide, please. So what we're going to be talking about is the elements of the pacing guide. What makes up these pacing guides? We'll specifically go through and just give you a highlight of all of the activities that comprise of the plant phenology and the carbon cycle guides. We'll try to do some demo and activity for you. And then we'll talk a little bit about implementation and take some of your questions and ideas and talk also about how we can go a little further with something that Brian Campbell from NASA Goddard is going to be sharing with us at the end. Next slide. So what are these pacing guides made up of? Well, when we sat down to design these pacing guides and talked to some teachers, we wanted to make sure that we were including an element of globe observation, going outside, making that observation. And through these pacing guides, we're going to be utilizing the Globe Program's app called Globe Observer as one of the means by which you could enter that data. Some hands-on component, as well as an activity from My NASA Data, which most of those activities are typically incorporating real, authentic NASA satellite data. And then we'll go through each of the sections that are in the guide. And so why don't we go to the next slide and we'll show you where in the guide you can find them. So when you're looking at the pacing guides, they're going to be in a PDF. And in the top left, you'll see the phenomenon that we're talking about. And so here in this case, we are talking about plant phenology. Next slide. Then you'll be able to identify the grade level because the grade level does change for these pacing guides, and that is dependent on the standards. And so you'll be able to see what grade bands we felt this was most appropriate for. And then something that is really important is the guiding question. This guiding question is how we determined which activities to include and which activities to exclude for the purposes of really trying to focus on 5 activities for a 1-week guide. So you will see questions related to that guiding question for each activity. So that way that can be the thread that you use to pull all these activities together. And then something that I think is really important is contact information. So from here, we have our guest tonight. Brian Campbell is the contact for this because he has done so much work in the development of the Globe Trees tool that's found in the Globe Observer app, and is also a part of a number of Globe activities related to measuring and observing trees. And then we have another section here for further investigation. So what might you do if you really like this pacing guide and you want to do more related to this pacing guide in Globe? Well, in this case, for both of these trees pacing guides, you could join the Trees Around the Globe student research campaign. Globe is known for having several student research campaigns that are run. And so this would be a really good opportunity to engage, especially if trees was something that was really interesting to you and your students. There's also this link here for how you can become a Globe trained teacher. So there are e-training modules, so you can do this online. There's also a way for you could do it in person if there's a workshop that's happening in person in your area. But there are virtual training options for how you can become a Globe certified educator. And that opens the door for you to join the Globe community, gain access to student accounts, if that's where you want to go with the program. And then, of course, how you can get back to the pacing guides. So if you just wound up getting this PDF, how can you get back to all of the pacing guides? The link that's listed there. Okay. So moving down in the pacing guide, we have standard alignment. And so these are the standards that are supported by the activities in the pacing guide, although they may not be fully covered, as you're well aware, as many of these standards are in depth. But again, this is how we looked through the activities, looked through the NGSS standards that best aligned, and used that to help select the grade bands. And then we also have included in here some background information. So within the PDF itself, there's going to be some background about the topic and about NASA's involvement in this topic of study as well. And so on this next slide, I figured because we're here together, I would go ahead and give you a little bit additional background information to the area and show you some additional cool resources from NASA. So this animation is our NASA's Earth observing satellites. And there's a lot. So for your students who might be thinking about NASA as solely really looking into space, that is not the case, right? We are using that vantage point of space and that amazing location of space to look back at our home planet as well. And one would argue it's maybe the most important planet because this is where we live. And you can see that there are multiple satellites, and that's because each satellite carries a different instrument, and each of those instruments measures slightly differently. You kind of think of it like your five senses. So maybe you have an instrument that is more visual with sight. Maybe there's one that is more like the sense of touch. So maybe it's measuring heat or temperature. And by combining all of those pieces of information, we get a much better understanding of what's happening. Plus, these instruments and these number of satellites are observing a lot of different features about our Earth. It's the atmosphere. It's also looking at sea level rise. We're monitoring our plant health. They're doing a number of things. And so that's why you have so many of them active right now. Let's go ahead to the next slide.
Did you know NASA keeps track of food production from orbit? Pioneering scientists of the 1980s realized that satellites could see plants growing from space. This monumental discovery occurred when NASA scientists figured out how to use satellites to measure chlorophyll in plants, which is reflected as green light into space. With a flood of new data pouring in, NASA, USDA, and the University of Maryland created an online tool that could track crop health anywhere in the world in real time. The team called the inaugural platform GLAM, Global Agricultural Monitoring. The system has withstood the test of time and is still in use today. Inspired by technological advancements and increased computing power in recent years, additional global agricultural monitoring systems have been developed, including NASA Harvest's GLAM-2. Here at home, when a massive derecho hit the Midwest in August of 2020, satellite data helped analysts to rapidly assess the damage. This natural disaster caused upwards of $4 billion in damage, one of the costliest windstorms of the past decade. Using Earth observation data for these types of damage estimates helps American and international markets prepare for potential commodity crop shortages. In the face of more extreme weather due to our changing climate, food security is one of the most important challenges of this century. NASA technology is helping keep our leaders informed, our markets stable, and our populations fed.
I think that video helps to introduce us all to why, just some of the reasons why it's so important that NASA is involved in the study of our home planet Earth, and in this case, in the study of plants, and using that vantage point in space to be able to measure the chlorophyll of the plants to really track the health of plants and the location of them. Let's go ahead to the next slide. Now, as you heard in that video, it was talking about NASA satellites. And that's what I was showing you too. And that is definitely a main emphasis for NASA, is using that vantage point of space. And so we do put instruments on those satellites, and even the largest man-made satellite, the International Space Station, also looks back at Earth with some Earth observing satellites. But interestingly, there are other platforms there we use that vantage point to measure what's going on Earth, and some of that is within our atmosphere or almost on the extent of our atmosphere, like CubeSats or balloon launches, putting instruments on those balloons. Here at NASA Langley, where I'm from, and Brian Campbell, who will be speaking at NASA Wallops, we do a lot of airborne field campaigns. So we put instruments on aircraft. You know, NASA's obviously very involved in understanding airplanes and aeronautics, but we also use those as platforms by which to put our instruments on. So we can go to specific locations around the world and measure what's going on and see how those measurements might compare to those of our satellites, and making sure that our algorithms, those mathematical equations that we use to calculate what's happening, are indeed accurate. We also use or of other platforms like UAVs, but if you go down to the bottom, you'll also see smartphones and citizen science. So this is where you and your students want to come in with the GLOBE program, where we can be assisting NASA in studying what is happening to our planet by participating in citizen science and even using our smartphones with our apps and these technologies to be able to contribute data, which I think is really exciting. Next slide. So one of the many satellites that we have is ICESat-2. And ICESat-2 is cool because it is one of the satellites in space that's using lasers. That's right, lasers pointing down from space back to Earth to tell us about our planet. So there's another satellite, Calypso, that measures clouds and aerosols. And here, ICESat-2, it's measuring clouds and ice, but it's also really known for making maps of land elevation and tree canopy cover elevation. And so these little beams, right? So they're small from a footprint perspective. These beams of laser light, those photons wind up coming down from the satellite to Earth. And when they bounce back to the satellite, that's how we know, because of the distances traveled, what that topography would look like. And I'm sure Brian will have a chance to tell us more here at the end. Next slide. And so when we talk about satellites in space, what's really cool about satellites from that vantage point is that they're normally able to do a good job of seeing the breadth of the globe, but sometimes the details are where we struggle with. And so by combining all of the observations from satellites, from UAVs, from the aircraft, and from your vantage point on the ground looking up, we're able to get a more complete picture, because each of those platforms, whether it's you on the ground or a UAV, everything has its own advantage and disadvantage. And even looking at this diagram here, you can see that the satellite in space looking down has a completely different vantage point of you looking up. And so that's the beauty of combining your globe observation with larger data sets from NASA. Next slide. So I'm going to pass it back off to Angie, and she's going to share with you all the details about these two pacing guides.
Thank you, Jessica. So we will share the link for this slide deck with you, and this page here is really just holding the links for you to access our partner page, which has all the guides, and the two that we're discussing tonight. So the plant phenology one, where the guiding question is, how are plants, land cover, and climate related? And then we'll transition from that one into trees and carbon cycle. And the guiding question for that one is, how are trees related to the carbon cycle? So you can see that these guiding questions, we can have a focus, and you'll see how that impacts the activities that we chose. For plant phenology day 1, the activity is the tree growth game. And in fact, this is also the same activity for day 1 in the carbon cycle. I'll describe the activity, and then we're going to do kind of a simulation of it. So this activity is, you will cut up little like blue drops of water, something to represent water, put it around the classroom, and then you have like little balls of paper, and those would be around the classroom. And one student will be the trunk of the tree, the person who draws the trunk. And when you tell the students to go, they'll kind of like go and race and try to grab either a water droplet or a carbon and bring them back to the leaves. So this is kind of a fun activity. It's really interactive when we do it in person. For every carbon and water pair that you get, the trunk person will draw one leaf on the tree, and for every 3 leaves, they will widen the tree. Okay, so since we can't really go run and grab pieces of paper together, what we're going to do is a Jamboard. And I believe Jessica has put the link in the chat. So we'll go out to the Jamboard, And what I'm going to ask you to do is we're just going to give you a few, 30 seconds to add a sticky note. So you go over here and click on a sticky note, and you can change the color. And so, add water and carbon sticky notes, blue for water and orange for carbon. And we'll see how many pairs we end up getting. So let's just do maybe about 30 seconds and we'll see how many we get. Okay, that's great. All right, so how many? We have 1, 2, 3, 4, 5, 6, 7, 8 waters. Do we have at least 8 carbon? Yes, we do. Okay, so on this next slide, I am not an artist, but you're gonna see my beautiful ability. So we had 8 pairs, right? So I'll have 1 leaf, 2 leaves, 3 leaves we've added to the tree. So now that we've added 3 leaves to the tree, I will widen the trunk a little. And so the students are starting to see how the tree needs water and carbon, and also note that there is sunlight, right? Because they need sunlight, and we are showing the soil here. Okay, so we added 3 leaves, and then we'll have 4, 5, 6. And I need to widen the tree again. And if I'm taking the liberties, I'm going to say their roots are getting bigger. And then we'll add even 2 more. Okay, great. So this is kind of a representation of the tree growth game. If I go back, you'll note in the picture that you can actually keep the carbons on the leaves, which is a good way to indicate that the carbon is being stored or sequestered in that plant. Okay, so that's the first activity, and they're seeing what does the tree need to grow. What does the tree need to grow is the guiding question. On the second day, we're going to do a chromatography activity with leaf pigments. And so this activity, you can do the long version or you can do an abbreviated version. The long version will include using a black marker, and you can do it with green leaves, and you can do it with fall leaves as well. If you don't have time to do all 3, then just do it with the green leaves. And they're going to be able to see in the chromatography that, that green, you can make that connection to chlorophyll. And then the guiding question will be, when do chlorophyll pigments typically decrease? Or you could have it when they increase as well. So that's the second day. So they're investigating the chlorophyll in the leaves. The third day, we're going to look at annual vegetation changes. And this is a MyNASA data activity, and it is a series of images that the students can evaluate, and it's for normalized difference vegetation index, which is basically a measurement of the greenness of Earth, which relates back to that chlorophyll. And then you'll see, when do the chlorophyll pigments typically decrease. What I did in the interest of time this evening is, instead of us going out and looking at all those images, I made it just a little screen recording of the images in sequence that goes, kind of quickly, so you can see the changes over the seasons. And I just looped it here a few times. So you can see the increases and the decreases in that greenness of Earth. And the students will investigate that and answer questions about it. Moving on to day 4, this is the day where we incorporate a globe observation. And so we give you the option of tree height and or land cover. Of course, since we're talking about trees, tree height is a great one, but it does relate to land cover. And if you recall those 2 pictures we looked at the beginning, and we looked at the differences, there were differences in those trees, and there were also differences in the land cover. So I'm going to show you a quick video on how to make a tree height observation as well as a land cover observation. So that was tree cover, and now we'll do land cover.
So Angie, can I jump in here for a quick second?
Sure.
So I just wanted to mention a couple things about the app, particularly, so in the trees tool, we are using your phone and turning it into a clinometer to measure height, which is really awesome. And then in the land cover tool, I did want to mention something in particular because it might have been hard to see in that video, but through land cover, you're going to be taking those photos of your site. And then in the app, there are a number of really good tutorials. So you'll need to click through a number of things to better understand what you're trying to do in the app in terms of estimating. And so I have, so in the app, there's a second little button once you've clicked on land cover. That first button lights up after you've completed those first set of tutorials, but you have to click on this middle button here to get the next set of tutorials to understand how you do estimation of what is on your land cover site. And so make sure you click on that, otherwise you won't get to that part in the app where it asks you to do those estimates.
Thank you, Jessica. So then we arrive at day 5 of our plant phenology, and this is a globe activity. And this is a little bit of it's a global green up and green down activity, but we're only asking you to do this part of it. So there are other parts in the activity. And this part has this graph of vegetation vigor and land cover descriptions, and you see those land covers on the map. And the students are asked to try to figure out which land cover type goes with which vegetation vigor graph line. So it helps bring them, from the perspective of one tree on day 1. Now we're going all the way to a land cover and a more of a regional and global perspective. And the guiding question, or the connection back to the guiding question, is, do you think changing climate, which is temperature and or precipitation, would have an impact on plant growth? And then after we do our day 5, we always have a connection back to NASA. So that connection is, how and why would NASA study trees and land cover? And we do provide an answer for you. So they're looking at these changes over time to give us information on how the planet is changing, including the timing of seasons shown by changes in plant phenology or green up and green down. Okay, so we also have additional resources available for each pacing guide in case one of the activities doesn't quite work for you or you want to customize it. Feel free. We made really difficult choices about which activities to include, but we know that educators are professionals and that they typically like to modify activities to meet their needs, and we're trying to make that as easy for you as possible. So this video here is going to transition into our carbon cycle pacing guide. So we're looking at that NDVI again, that greenness, as well as carbon dioxide changes over time. So we can see that the northern hemisphere has a lot of vegetation changes, and you can see that the carbon dioxide increases when there's not as much vegetation going on, and that those plants then remove some of that carbon dioxide as the vegetation increases. So for trees in the carbon cycle, day 1 is still the tree growth gain, because you still have that idea of those trees sequestering some carbon. On day 2, we have this activity called allometry, not allometry, which that always makes me laugh. But they can look at a tree, look at the height and the circumference, and figure out the biomass of the tree. And then this activity has pages of categorization so that you can figure out which of these 10 categories the tree likely is in. And then based on this graph, you can figure out the predicted biomass, and then half of that predicted biomass would be carbon. And so the connection back is how much carbon is your tree storing? Okay, so day 1, they see that the carbon is stored. Day 2, how much is a particular tree storing? Then on day 3 is the day for those globe observations that we've already talked about. Day 4, we have a MyNASA data activity called carbon dioxide production and sequestration. We have this gridded image, and the parameters are provided in the lesson so that they can estimate the amount of carbon that is being sequestered in the forested areas versus the deforested areas. And then there's a home on here, and they talk about the carbon footprint of the home, and then they predict what would be the impact of adding 50 more homes in this area. And connecting back to the guiding question, it's how does the carbon stored in a wooded area differ from the carbon stored in a barren area? Oops, sorry. And finally, on day 5, there is an animation of the carbon cycle and a discussion. And then the students can draw a carbon cycle for their local area, their neighborhood, and answer the question, what role do trees play in the carbon cycle around you? And then the connection to NASA, why does they study tree height? It's a different answer in this pacing guide. It helps determine the amount of carbon being stored or being lost, and helps determine changes that might be occurring that might impact climate or land cover. And so that is the 2 pacing guides. And Jessica, if you could take over for me because my voice is getting really tired, that would be helpful.
Sure, not a problem. So feel free to type in the chat if there are particular things about this pacing guide that really stand out to you for how it might be helpful for you to implement it in your educational setting. Some of the things that we have heard from some of the teachers that we've worked with is that they're happy that the planning, so to speak, is already done. It took us some time to identify the guiding question and then 5 activities specifically supporting that guiding question. So that part of the planning is already done. The assessment is built into that pacing guide. So when you look to the far right column of the activities for each day, there is some recommended assessment if you wanted to build that in. Thinking about this, the questions, so those guiding questions, really build a story. So they could be doing storytelling without having to go in-depth data analysis, right? So there's only a little bit of data that they're looking at depending on what MyNASA data activity. But really thinking about it for those of you that are interested in storytelling with your students, maybe leveraging that guiding question to do that. And then remembering that we really designed this with the intent that this would be a flexible tool for you as educators to choose what activities would work best with your students. So feel free to swap in and out any of those additional resources that you see or other ones that you know about. And like I said, if you have any other suggestions, feel free to put those in the chat regarding implementation. Next slide, please. So now we want to invite Brian Campbell to talk a little bit about a really interesting tool that I think you'll like to tie back your globe data to NASA data.
Thank you, Jessica. I like that. We'll share for no more than 5 minutes. All right, let's go.
Keeping us honest.
Yeah, for sure. All right, so what I I put in the chat the 2 things I'm going to show you, and something is newly released and something, they both can work together very well. So
do you need me to stop sharing, Brian, so you can share?
Please. Yes. Okay. So the first thing I'm going to just show you is something that was recently released, and this is Jessica. I should also mention, Jessica mentioned earlier, the ICESat-2 mission, the Ice Cloud and Land Elevation Satellite 2. And it's a mission I've been working on since the formulation of it like 13 years ago. And I worked on the original ICESat satellite. But as Jessica mentioned, this is using basically sending laser photons from the satellite, which is about 400 miles above the Earth's surface, down to the ground, and it's bouncing off of objects like the ice sheets in Greenland and Antarctica, glaciers, trees, buildings, mountains, landforms, all these things, oceans, bodies of water, to figure out that third dimension, that height variable. And with this, it's really cool because, even though its primary objective is looking at the changing ice for, as a climate change satellite, it's able to measure the tree height. So what this app does is, and it's available, and you'll see here, on both, it's available for Android and iOS operating systems for your mobile device, is that what you can do is you can go in and take a look at when ICESat 2 will be near you. Now, two things here. The older one is the one for Android, and it has a couple more really cool things that the iOS one can't do yet. So you can look, at the past of when ICESat 2 is near your area, but also you can look at when ICESat 2 will be near you in the near future. So, for instance, if you're out taking NASA Globe Observer Trees Tool observations, and you want to know if ICESat 2 also took tree height observations, you can plug your latitude and longitude in of the tree, because as you know, if you do use the trees tool, the tree that you measured will have a latitude and longitude associated with it. It'll be geolocated. So you can plug that into latitude and longitude, or if you just want to, if you have your your location services turned on your mobile device, and most of us do because we use maps a lot on our mobile devices, you can hit use current location. So what you do is you put in there, what your parameters are, what your latitude and longitude are, and then the search radius, and it's up to, I think, 25 miles is the max you can do. And then it will pop up and show you exactly what time ICESat 2 will be flying near you and where. And the one for iOS, which was just released a couple weeks ago, it doesn't have the capability to go back and look in time of when ICESat 2 was, but it's going to have that. But it looks at the future. So I happened to look at it for my location, and it just did happen. I looked earlier, and it happened February 22nd and 24th. And the next time it's going to hit near my area in Salisbury, Maryland, is going to be, I think it's around March 21st or 22nd. So that's a little bit about ICESat 2. But this is, you can go onto this site and go to that and find out how you can download this for your device. It's a free app. You don't have to register or anything, and you can just plug your info in and go with it. So with that said, if you want to know where ICESat 2 is, to see if ICESat 2 took tree height observations in your location of the same trees that you took tree height observations of using the NASA Globe Observer Trees tool, okay, that's great. So once if you find out that ICESat 2 did, you can then go to this tool called Open Altimetry, and it's an online tool. It's originally created for researchers, but being the lead for the Trees Around the Globe student research campaign, we've adapted it a bit to, or fine tune it so that anybody can use it. There are some, things on it that are pretty difficult to use and figure out, very, very technical things. But I'm going to show you here just how easy it is to potentially do and see, what the tree height looked like from ICESat 2. And I'm just going to go randomly here because of the time. But if you click on this red button, browse ICESat 2 data. Okay, and what's going to happen is a map of the world's going to open up. And what you're seeing here are all these green lines. These are the most recent orbit paths for ICESat 2. Well, I'm going to zoom in a little bit. I can just use the arrow. Let's go back over here to the United States. You're going to see a lot of little red lines pop up. These are older orbit paths, and it takes a little while to render sometimes, depending upon who's using it and bandwidth and everything. Now, that's a lot, right? So there are lots and lots of them. So I'm just randomly going to go in here and just zoom in pretty close, let it render a bit, and find an area where there's trees. Well, lots of trees. So what you can do is you just find one of these orbit paths, and if it's near your location, that's great. Well, what it's going to do is when you click on it, it's going to say data availability, and the drop-down menu, it'll tell you the track. That's just the official track number for the orbit track number for ICESat 2. And you can click here and it'll show you the dates when it was nearby, either east or west, okay, of this location. So I'm just going to randomly click on some of these to see what pops up. All right, and don't see any yet. It's kind of a hit or miss thing. And over here you can see there's a calendar and everything. So yeah, so there's one that popped up. You see a calendar. You can, if you measured a tree on a specific date and you found out, the ICET2 hit that location on the same date or close to it, because if you're a couple months difference, you might not get a total huge difference of tree height. But I'm going to show you quickly right here in the next couple minutes how to do this. And if you click the select a region at the top left, it's a blue button with white text. Click on that and you'll get this little hatch mark, this plus sign. And you can then, you hold the mouse down and you just highlight all these dots. And these are the photons that Jessica and I talked about that are coming down from ICET2. These are the ones that actually hit the ground, hit an object on the ground, and bounce back to the satellite. So when you let go of the mouse, this box will pop up. And what you want to do is click on View Elevation Profile. And when you do, another window will open up. And you'll get two things. The top graph you'll get, it's a ground elevation canopy surface. So it's aligning all these photons. You'll see these different colored photons. This happens to be, this pair happens to be green and yellow. Okay, all the photons are green from ICET2, but this is just representing because ICET2 fires out these single laser pulses, but the single beam breaks up into 3 beams, and each individual beam breaks up into another one. So you essentially have 6 laser beams, basically 3 pairs of laser beams. So it's able, ICET2 is able to measure the elevation of the surface as it's measuring the height of the things it's trying to measure. All right. So we have the ground elevation right here and canopy surface. So that's the elevation. But what we're really excited about here are the canopy heights. And you can see we went through a very densely wooded area. And all these dots are representing tree heights from ICET2. So let's say, you line up your latitude and longitude, right? You can see up here is the latitude, and you match it up to what you have in the NASA Globe Observer, what your observation is. And let's say it's this one here. And you went in and took an observation of your tree height was like, 9.5 meters. And you can go and you can see here that ICET2 measured it at 8.83 meters. So, you can then do some comparisons between the two. And one thing I should mention, and Jessica kind of mentioned this earlier, is that we're talking when the laser photons hit the ground, it's called a footprint. And when the laser pulses from ICET2, when these photons hit the ground, this laser footprint, the photon footprint, is approximately 13 meters in diameter. So it's basically creating this 13-meter diameter footprint on the ground. And what happens here is however many trees are in that 13-meter diameter footprint. For instance, if there are 100 trees in that 13-meter diameter footprint in a very densely, tightly packed forest, okay, whatever the surfaces of those trees are that are kind of at the top, not a lot of understory, what's going to be returned to the ICET2 satellite is the average height for all the trees in that 13-meter diameter footprint, okay? So there's different ways that you can see if your data compares. If you measured a bunch of trees in a small area and you saw ICET2 hit that, you can then take all your tree observations and add them together and then take the average of all those trees and then see what ICET2 saw, see if it matched up. On a rare occasion, and I was able to get one in Salisbury, Maryland, in my neighborhood, I got ICET2 dropped the photon that touched just a single tree, because it was a tree next to a pond and there was nothing else around, no other trees around it for that, in that 13-meter diameter footprint. So it basically 6.5 meters in all directions. There were no other trees, just this one tree. So that's what's really cool about this, is that you can essentially find that type of stuff. It's rare, but it's actually a fun search to try to figure out. And this is a great extension to the pacing guides in taking that data to the next level. So the final thing I want to show you here is, and there's a lot on this image, I apologize for that, but this is showing you some really cool things here. So this is showing you basically, it's a kind of a mosaic of everything that I put together with what I just told you. We have, let's go up here. We have in the yellow, this is ISET2 measured the tree height in this area. So it's a combination of a bunch of trees and then the average of 21.36 meters. I went out and took observations of as many trees in that footprint as I could, and I got an average of 18.93 meters. So that makes it a difference of about 2.43 meters. Not too bad. Okay, that's still really good. And then um, in the green here on the bottom right, same situation. A bunch of trees here, 17.78 meters from ISET2. NASA Global Observer tree heights that I got is 18.554. So it's under a meter difference in the tree height. Now, the reason why there's two different colors here, these are the photons, kind of like I just showed you. This is part of a pair of laser beams, the photons that are part of it, one of the pairs of the three pairs of laser beams from the 6 beams. And what we have what's called a strong beam photon and a weak beam photon. And you can learn more about that on the Open Altimetry page. But this is just an example of what you can do. You can then, take your observations and then see if ISET2 measured it, or you can go to the app or go directly to Open Altimetry and find out if ISET2 hit the trees in your area or nearby or somewhere you're going to travel, and then go out and take NASA Global Observer tree height observations with the NASA Global Observer trees tool. So I just wanted to showcase that a little bit, and the links are in the chat, as I mentioned. And if you have any questions, I'll pop my email in the chat as well. And it's also on, as Jessica mentioned, it's also on the 1 week pacing guides for me as a contact. But I'll put that in the chat just in case. So let me pass it back over to Jessica and Angie.
Thank you so much, Brian. I just was mentioning in the chat how oftentimes I hear educators talking about the need to do integrated STEM, and I think NASA missions are quite the example of that. And I think throughout this session today, we have touched on all of them, and maybe that's an idea. If any of you want to take this pacing guide and go one of those directions, there's a lot of opportunity there. So thank you, Brian, for sharing that and really helping us connect directly with NASA. So to close out, we wanted to mention, remind you of the other pacing guides that we do have. There's one specifically related to mosquito habitat. There are 3 that use the clouds tool. So that's air quality, cloud types, and clouds and energy budget. We've been talking about using the trees tool and land cover tool for plant phenology and carbon cycle. And then we'll be talking, the next one that we are going to actually be doing a webinar on is urban heat islands, and we'll be particularly highlighting the land cover tool. And so I believe that date is March 23rd for that webinar, if you are interested in joining us for that one. And I think we have some time for a few questions. Again, thank you very much for being so interested in supporting your students and integrating authentic science with your students that you have joined us this evening or have been watching the video. We really appreciate all that you do as educators. So at this time, we'll go ahead and open the floor for questions. Catalina, yes, these webinars are recorded. And in fact, we have already posted the first one that happened. It is on that same website. Let me drop the link in the chat for the pacing guides. And our intention is to post all of these webinars on that link for where you find the pacing guides. So if you missed some of today's session, or if you want to go back and get a refresh for a different pacing guide, they'll all be there. Thanks. I see a question. Oh, go ahead.
I just wanted to give a special thank you to Brian for joining us. And Mike is asking for the slides.
Yes, let me drop that presentation link. Thank you for reminding us. Here is the presentation link with the slides. And I see a couple questions about phenology. If you are interested particularly in phenology, I encourage you to go to the Globe website and look under the Globe Teacher's Guide specifically for the Green Up and Green Down protocol and corresponding activities. I'm going to find that here in a second and put the link in the chat. I'm sending you to the link that has the protocol information for Green Up and Green Down, but all of these Globe protocols are also available through the thing I was mentioning, this e-training. So there is training, virtual training on the Globe website for those of you who want to become Globe certified educators. And you can, the way that the training works is you take an intro to Globe training. You'll take an intro to the sphere, so in this biosphere, and then you could do, say, whichever one of these biosphere protocols you're interested in, such as green up and green down. And those of you that are interested in biosphere in particular, there's obviously a lot of connections with all of these, but you might also be interested in urban heat islands as well as mosquito habitat.
Brian, do you see the question from Betsy? Assuming we can determine when ISAT2 flies over, if we went out to take measurements, how long does it take for the data to upload for us to do a comparison between our measurements and ISAT2? The kids will love it.
Are you asking how long it takes the ISAT2 data to show up, or your NASA Globe Observer Trees tool data?
She said yes. ISAT2.
Okay, ISAT2. Well, ISAT2, there is data latency because the data has to be processed, one, and two is that you can, probably go back and look at some, past ISAT2 data because, it only goes back about 3.5 years. So, because ISAT2 was launched September 15th of 2018. So yeah, if you see that ISAT2 is flying over your area in March, the latency right now, actually, I'm going to go pop on open altimetry quickly and look because I don't know the last date that's up there. So it looks like, so it looks like the last date, and these are getting faster and faster all the time with the processing. The latest date that's up there now is December 22nd of 2021. So there is data latency involved with that, but that's one of the issues with it because there's basically over a terabyte of data coming back from ISAT2 every day. So it takes a little while to process, and then they have to make sure that, they have to look through the algorithms and filter out any of the noise, the photon noise and all that stuff in order to get it up on a site like Open Altimetry. So yeah, so my suggestion is if you happen to do that and see it, go back and look, further back in the time because ISAT2 has what's called a 91-day repeat orbit. So it basically hits that same location every 91 days. So essentially, if it is about to take an observation, there's a good chance that it took an observation before. Even though it may have hit your location, if there's lots of really heavy clouds or even some cirrus clouds, that interferes with the photons hitting the ground because the ice crystals in a cirrus cloud can refract that light in every which direction, so it won't make it to the ground. Or if it even bounces down, comes back up and hits a cirrus cloud, it can get scattered. The light gets scattered, as well as if the clouds are too thick, we won't be able to, the photons can't penetrate that really thick cloud. So, that's one tricky thing that's involved with that, with the algorithms as well to filter out any noise. But yeah, great question.
And Brian, I'm sorry, go ahead, Jessica.
No, go ahead. And then
Can I clarify that it's the ISAT2 app? If you have the iPhone, you can't necessarily look back, but for open altimetry, you can look back.
Yeah, the app will tell you where ISAT2 was. It won't tell you the tree heights or anything. The app won't. It'll just tell you location, on iOS, the future path of ISAT2, where it's going to be in the area. The one for Android, it'll show you future and past. But open altimetry, you can look at all the data. you can look at the past, present, and it'll tell you the tree heights, elevations, and all that stuff.
Thank you.
Sure.
Since there is so much interconnectedness when we talk about phenology, I know that our colleagues and friends that do the mosquito campaign are also planning a webinar March 10th, I believe it is, where you may be hearing about a potential bio-blitz type activity looking at spare tires and mosquito phenology. So I'm going to drop the link in the chat to if you want to join that webinar, which I believe is March 10th. And so Cassie, if there's anything you want to add to that, feel free to unmute.
Thank you, Jessica. It's 2 p.m. Eastern time with the link that Jessica dropped in there. So we'd love to have you join our campaign to take observations wherever there could be a tire, because that's where the water's warm early in the dark tires. So join our Phenology mosquito campaign.
For all of this phenology conversation, the quick definition that I tend to use about phenology is the change in how living things change with seasons. And so that could be animal related. So when we think about migration patterns even, or it could be plant, right? So it could be plant phenology like green up and green down. So when we're talking about phenology, this is really on the bio side of the house, life science side of the house, any living thing, how it changes with seasons is really what we're looking at in the study of phenology. And so in this case in Globe, you have the opportunity to look at it through, say, plants and looking at trees, or as well as some of the other animal ones, and mosquito habitat is a great way to kind of combine that by being interested in mosquitoes, by being interested in their habitat in particular.
Jessica, I see a question about being certified, but looks like they're in a different state. And I don't think it's that you need to restore your credentials, but maybe you could advise this person on how to change their organization.
Yeah, if you have, if you've been trained in the past, Globe has been around luckily for more than 25 years. So there's a lot of history there, and you're trying to get your certification recognized now that you've changed around, or maybe you haven't logged in into a long time. Honestly, the best way to do it would be to contact the Globe Help Desk. So there is a contact form that you can use, as well as a phone number that you can use that I'm going to plop in there. And then Brian or Angie or Cassie, if you have the email address, because I know we changed it to the UCAR email address recently. So I'm dropping in the link to the form, which also, by the way, has a phone number where someone will answer, which is amazing that programs still have people who are answering the phone. Just note that the Globe implementation offices run out of UCAR, which is in Boulder, Colorado. So they operate on Mountain Time. But that would be honestly the easiest way to track you down, is just giving them your name, your email, what school you think you were at when you first got trained. And then this way they can update to your current school. Certification follows the teacher. Many years ago, we may have done certification a little differently in Globe, but certification follows the teacher. So once you are certified, whether that's an in-person training or through e-training, that goes with you to whatever school or organization you wind up moving to over time. So you take that with you. You're very welcome. Any last minute questions? I will also go ahead and plop my email address in here in case something comes up. Jessica.e.taylor@nasa.gov is my email address if you have any Globe questions. Angie is angela.rizzi@nasa.gov, We would be happy to hear from you, especially if you've tried to implement it. And if it worked, great. If you have suggestions for how we can improve this in the future, we would also love to hear about that. Phenological gardens, there is information on the Globe website about phenological gardens as well. And those of you interested in phenological gardens, if you would email me at jessica.e.taylor@nasa.gov. We have a Globe partner out in Boston who actively does phenological gardens there. And so we might be able to connect you if that's something you're interested in. Okay. We'll do one more minute. Any more questions? We appreciate you all staying on so long. It's hard sometimes to fit 2 pacing guides into one session, but I think we did it.
Thank you. Thank you, Brian and Cassie.
Yes. All right. Well, we appreciate everyone's support in putting these together from all of the NASA Science Activation Teams, Globe Mission Earth, and NESIC. We're doing this all because we know how much educators need resources like this, and really because we appreciate you as educators. So thank you for all that you do, and we hope to see you at the next webinar on March 23rd, or feel free to contact us in between. Thanks so much, everyone. Bye.